So the first couple problems here ask us to actually look at application problems to talk about domain and range. So let's look at the first one. The fine for speeding in a school zone is $200 plus an additional $50 for every 10 miles per hour over the speed limit of 20 miles per hour. The additional fine begins when a car is clocked at 30 miles per hour or above, but the total fine cannot exceed $500. We're going to come up with the domain and the range. Okay. Talk to me about the domain. The minimum is what? Not for the domain. Let's go back a little bit. What's the independent variable and what's the dependent variable?
Speed.
Good. The independent variable is speed, and the dependent variable is money. Okay. So our independent variable is speed, which means that's our domain, right? And our dependent variable is the cost of the ticket. So that's our range. So let's think again. What's the smallest value for our domain? So let's think about it. Are you going to get a fine for going 20 miles per hour?
No.
What's the first value you could potentially get a fine at, though? 21. 21. It says the additional fines begin at 30, right? But technically, they could charge you that base fine of $200 if you're going 21 miles per hour. So for our domain, are we going to be able to do this in inequality, or do you think we're going to do it in roster? Yeah, because you're clocked at actual miles per hour, right? So I would say we would start at 21 miles per hour. Go up to 22 miles per hour, 23 miles per hour, and we could keep going, right?
So if there's like a lot of numbers after, you can just put dot, dot.
If it follows the same pattern, yes, you can use the dot, dot, dot. All right, let's talk about the range. Say you do get pulled over for going 21 miles per hour. What is your fine going to be? $200. Good. And then that stays the fine for a little while, right? Then what's the next value of the fine? 250. And what's the next value of the fine? And you can continue listing out, but since it follows the same pattern, we can say dot, dot, dot. But we do have to end this one, right? What does this end at? $500. Okay? All right, look at number 2. A typical cashier at a grocery store can check out customers at a rate of 10 customers per hour. There are a total of 20 checkout stations, but not all stations are necessarily operating at one time. The total number of customers, N, who can be checked out, is given by the function N equals 10 times C, where C is the number of cashiers working. What is a reasonable range for this function? Okay, so first of all, what is our range talking about? Is it talking about the number of customers, or is it talking about the number of cashiers? Number of customers. How do we know? Good. Those are dependent variables, is the number of customers. That depends on the cashiers. All right. So what is the smallest number of customers that can be checked out? What do you think? I think 0 is probably the best one. Because couldn't the store be closed at a certain time? And be checking out no customers per hour? So I would personally start with 0. We're coming up with the range. Okay? All right, so that's if no cashiers are working. What if one cashier is working? 10. What if 2 cashiers are working? 3 cashiers. All right. And what's our maximum range value going to be? 200. How do you know? Good. The biggest number I can plug in here for C is 20. Everyone okay with that? All right. So we'll do some application problems like this. It just kind of forces us to think a little bit. But our real goal today is to talk about coming up with domain from equations of functions. Okay, so we're going to be practicing inequality and interval notation for these. All right, look at number 3. Number 3 says f of x is equal to 2x minus 10. Okay, we can think about this a couple of different ways. If I were to graph this, what would the graph look like? Okay, so the y-intercept would be negative 10. It would increase by a slope of 2. What would the picture end up looking like? It'd be what shape? What do we call that? A line. It's a line, right? And a line has arrows on either side. Okay. All right, so this is a linear function. And a linear function goes on forever in both directions. So are there any restrictions on the domain of a linear function? No. So what would we say the domain is? All real numbers. Okay, so let's remember how we write that. We would say x is an element of, remember it's the little e with the curvy, all real numbers. Okay, because the other thing you want to think about is I can plug any x value I want in there, right? I can plug in negatives, I can plug in a fraction, I can plug in 0, and I can still get a y value. I haven't broken any math laws. Okay, how do I write all real numbers in interval notation? Good. Negative infinity to infinity. All right. What type of function do we have on number 4? This is a quadratic function. What's the shape of a quadratic function? A parabola. What do you know about the domain of a parabola? Again, it goes on forever in both directions, right? So it's all real numbers. So anytime you see a linear, quadratic, often cubic, things like that, and you have no restrictions, your answer is going to be all real numbers. Okay. There are 2 specific domains that you are going to be looking for when you look at equations. Okay? There are 2 specific domain restrictions that you're going to be paying attention to. And these domain restrictions are really, really, really important. It is what? Day 4 of school? Okay? I will go ahead and tell you, this will show up on after parties. This will show up on your semester tests. This will show up on semester exams. This will show up on your final exam. I want you to leave here knowing how to find the domain from an equation. There are 2 rules you have to memorize. That's it. Can we do that? We can do that. Okay, so the first rule is that the denominator of a function can never be equal to 0. Have you ever tried to divide something in your calculator and you got an error message that said div by 0? You ever seen that before? That means divide by 0. You are not allowed to divide by 0. It is against the math law. Okay? Dividing by 0 is undefined. Can't happen. Okay? So we can never have 0 in the denominator. So here's how we find the domain anytime you see x in the denominator. So let's write ourselves a rule. When you see x in the denominator, so when x is in the denominator, you're going to set the whole denominator not equal to 0 to find out what x can't be. So anytime you see x in the denominator, this is your rule. You set the denominator not equal to 0. And why do we do that again? Finds out what x can be, but why do we have a restriction here? What are we never allowed to do? Divide by 0. You are never, ever, 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 ever allowed to divide by 0. That will be a rule the whole way through. Okay, so look at number 5. If I look at number 5, do you see x in the denominator? Yes, so that's red flag. Flag goes up. Sirens go off in your brain. Okay, how do we deal with an x in the denominator? We take the whole denominator, which in this case just happens to be x, and what do we do with it? Set it not equal to 0. Okay, so do I have any solving to do there to isolate x? No, we just know that x can't equal 0. So what that means on a number line, if I were to tell you to graph that on a number line, what would that mean for our domain? Good, there'd be an open circle at 0, and then what everywhere else? Yeah, shading everywhere else, right? It can be any number I want, any number at all, except for 0. So how do we write that in inequality notation? We can say that x can be all real numbers except what? 0. Okay. Use that number line to help us turn this into inequality notation. What's the farthest left I can go? Negative infinity. Up to what? I got to skip over 0. So I got to put 0 in here. What's going to be around 0? Parentheses, because I don't want to be equal to 0. That's the only thing I got to skip. Then we put our union to show that we're skipping. And then what? 0 with parentheses to infinity. All right, look at number 6. What's the red flag? You see an x in the denominator. So what's our rule? Good. Take the whole denominator and set that whole denominator not equal to 0. So what does that mean x can't equal? Good. So how would we write that for inequality? You technically could just leave it as x doesn't equal negative 2. You could also say that x is an element of all real numbers, but x can't equal negative 2. I'll accept just x can equal negative 2. Okay? How would I write that as interval notation? Up to what? Negative 2. And then a union. Negative 2 to infinity. If you're having a hard time making the jump from seeing how do we get the interval notation, please draw your number line. It will help you. Okay? Interval notation is really clear from a number line. Okay, can x equal 0 in this problem? Yeah. What happens if I plug in 0? What is my denominator? 2. And I'm allowed to do that, right? So it's not that x can equal 0. Excuse me. It's that the denominator can equal 0. So try and keep yourself from getting caught in that trap, okay? All right, look at 7. Do we care at all about that negative 7x on top? No, not important at all. All we care about is that there is an x in the denominator. You see it? So that's our red flag. That's the sirens going off in our head. And when we see an x in the denominator, what do we do? Good. Set the denominator not equal to 0. So what does that mean? It means 2x can equal what? 1. And x can't equal 1. All right. Go ahead and turn that into interval notation for me, please. right, so as an interval, what would this be? Perfect. All right, cool. That's domain restriction number 1. You can't have x in the denominator. Well, if you have x in the denominator, you know you can't divide by 0. So you set the denominator not equal to 0. All right, flip it over for domain restriction number 2. All right, domain restriction number 2. The radicand of a square root can never be negative. What does the word radicand mean? It's actually the one inside the square root. The number inside the square root is our radicand. Okay? The radicand of a square root can never be negative. We know that, right? We've tried to take the square root of a negative number and it doesn't work. Okay? The square root, when you take the square root of something, it has to be positive in order to get a real number answer. Now, later on this year, we'll talk about what does happen when you take the square root of a negative, but not right now. Okay? So, the radicand of a square root can never be negative. So, when you see x under a square root, think about what we could do. Here's a question. Can you take the square root of 0? Or can we do it? Yeah. What's the square root of 0? 0. Totally acceptable. Okay. So your radicand, it can be 0. It can obviously be positive. What can it be? Negative. So we want to set the radicand greater than or equal to 0 so that we account for only getting rid of the negatives. Okay? So when you see an x under the square root, your job is to set the inside, or the radicand if we want to be technical, greater than or equal to 0. Because we can take the square root of 0, and we can take the square root of positives, but we cannot take the square root of negatives. Yeah, a little bit, definitely. Okay, this tells us what x can be.
We're ready for the winner. T, all students. 9, 10, 11, 12, last name, letter T. If you do not have a digital peers ID, if you have not been issued an ID, please report to the library at this time. Any students, last name, letter T, or any students with last name, letter S who we missed, grades 9, 10, 11, 12, if you do not have an issued ID, please report to the library at this time. We will issue a digital peers ID. Thank you.
Okay. So let's give it a try. This is your second red flag, your second siren. Okay? So look at number 8. Do we see x under a square root? Yes. Okay. We see x under a square root. So we go find the whole thing that's under the square root. In this case, it's just x. And what do we do with that x? Greater than or equal to 0. Because if you remember the y, you'll get these rules. Okay? The y is that we can't take the square root of a negative. Only 0 and positives. So we set it greater than or equal to 0. Okay? We set it greater than or equal to 0. So that's our inequality notation. What would this look like in interval notation? If you have trouble seeing it, plot this on a number line. What would happen at 0? It'd be a closed circle at 0, and we would shade bigger numbers, right? So turn that into interval notation. Bracket 0 up to what? Infinity. It's always a good idea to put the inequality on a number line if you're having trouble transferring it to interval notation. Okay? All right, look at 9. Is there a siren or a red flag going off there? Yeah, what is it? Okay, we see an x under a square root. So we take the whole radicand and set it what? What? Very good. Greater than or equal to 0. All right, so what is, if we solve that, what does that tell us? Good. X must be greater than or equal to -4 for this function to be defined. If I try and plug in a -5, will I be able to get an answer here? Think about it. If I plug in -5 and I add 4, I get -1, right? And I can't take that square root. So that's not part of the domain. The domain starts at -4 and only gets bigger. Okay, as an interval now. Very good. All right, look at 10. Does the 2x outside matter? That's the only thing that matters. Good, the 3/4x plus 1 inside. What do I do with it? Good, greater than or equal to 0. All right, go ahead and simplify that to get your inequality domain, and then rewrite it as an interval for your domain. So you should get 3/4x is greater than or equal to -1. What can we multiply both sides by? 4/3. So what must x be greater than or equal to? -4/3.
Don't you like switch the sign?
It's a good question, but you only have to switch the inequality sign if you multiply by a negative number. Okay, since we're multiplying by a positive 4/3, we don't have to. Okay, all right, so as an interval, this would be -4/3 up to what? All righty. So these have all been square roots, right? Let's talk about what happens when we have cube roots, fourth roots, fifth roots, sixth roots, that type of stuff, okay? A cube root is really nice because a cube root has no restrictions. Okay? A cube root, when you see that 3 out there, a cube root has no restrictions. The reason is we can take the cube roots of negative numbers. Okay? So if it has no restrictions, that means the function goes on forever in both directions. So what's our domain? All real numbers, or -infinity to infinity. Okay. A fourth root, on the other hand, a fourth root is going to work just like square roots. Because think about if you start with a negative number, if you multiply it by itself 4 times, you're going to end up with a positive. Negative times negative is positive, times negative is negative, times a negative is positive. Okay? So fourth roots act just like square roots. Fourth roots and sixth roots and eighth roots and 10th roots and any even root act like square roots. So we have the same domain restriction that we had with square roots. So how would we find that? Take the inside and do what? Greater than or equal to 0. So this is 7x is greater than or equal to 1, and x is greater than or equal to 1/7. As an interval, what would that be? Very good. All right, so there's two things we have to look for. Those are the only two things you pay attention to in an equation. If an x variable is under a square root or an even root, or if a variable is under your denominator, in your denominator. So look at number 13. You remember what those bars mean? Good, they're absolute value. We're going to talk about absolute value more in a couple days, maybe weeks, pretty soon. Okay? Now, we might not remember exactly what absolute value means, but is there an x in a denominator? No. Is there an x under a square root? So do we have any restrictions? No. So what's our domain? All real numbers. You're only looking for those two red flags, those two specific restrictions. Look at 14. Do you see x in the denominator? Do you see x under a square root or an even root? So what's your domain? All real numbers. What does the domain of all real numbers mean? What's A? X. Good. You can plug in any number you want for x and get an answer. Okay? That's one other quick mention I wanted to make. It reminded me, thank you. On your after party and in general, if you are explaining something, you've got to work really, really hard to never use the word it. It is like a bad word in here, okay? Because once things get more complicated and once you get into calculus, it could mean like 5 different functions, okay? So you gotta push yourself to not say it. All right, let me pass out your homework.